So at this point, you can pause and maybe think about what are the advantages and disadvantages of inclusive and exclusive policy before you go ahead with this. I'm going to explain that in the next slide. So let us first look at what are the advantages of inclusive policy. Why would you want to put the data in both L1 and L2? So one of the advantages of inclusive policy is that the evictions from L1. So if you evict something from L1, you do not fill that up in L2. So in an exclusive policy, you do this. So what you do in exclusive policy is, if you just go back to that slide, L2 is just filling up whatever you evicted from L1. So whatever you evicted from L1 is filling up L2. But in case of an inclusive policy, you don't do that. If L1 data from L1 is evicted, do not fill up L2. So basically, you save a lot of power, and also the clean lines are just evicted silently. So, I mean, whatever data you evict is just evicted silently without clogging up L2. The other advantage is that an L1 miss might still lead to an L2 hit, because going by the same policy again, so you do not remove the data from L2. Sorry, we'll go back to inclusive policy here. So in inclusive policy, since we had brought in the data into both L1 and L2, and at some point in time, let us say we evict X from L1, but it is still present in L2 because we had brought in that content already. So there is a chance that it can hit in L2. So there is that small advantage. Of course, that advantage exists in exclusive also, because you are anyway copying it into L2 cache, but this advantage exists in L1 also. So basically, whatever, since we had brought in the data into both L1 and L2, and we evict it from L1, there is a chance that it can hit in L2. So there is that advantage because we duplicated it. And this is this cache, this inclusive cache is also advantageous only if L1 is small, because you do duplication, but then the amount of duplication is less, and that duplication might actually help you in getting L2 hits if there is an L1 miss. So that is the only advantage with inclusion. Of course, there are a lot of disadvantages. There is wasted capacity because you're just duplicating the L2 cache. Of course, the advantage is that the L2 is much, much larger, so you have space to do duplication, but the capacity of the cache is wasted. And there's a lot of effort to maintain inclusion. So at every point in time, whenever you bring in data or you evict data, you have to maintain inclusion, and there is a lot of effort to do that. There is also more latency because you need to fill up the data in the two levels of the cache. And if there is an L1 miss, there is also a higher chance. So one part of the story I have told here, that there is an advantage of duplication, but there is also a disadvantage in duplication. Now the disadvantage is that let's say L1 is four blocks of data, and L2 has much more data. So now half of this L2 cache is filled up with L1's content. So there is only less amount of data present in the L2 cache other than whatever you duplicated. So there is less space for new data. So what that also means that there is a higher chance of an L2 miss. So let's say you miss in L1 and you have to search in L2. Half of that L2 is nothing but the content of L1. So the likelihood of finding the data in L2, or the likelihood of an L2 hit, will be lesser because there is only less space to put in that data. So as compared to an exclusive cache, in an exclusive cache, what would happen is that you have this L2 cache, which is entirely containing new data, which does not exist in L1. So therefore, if there is an L1 miss, then the chances of an L2 hit is higher in case of an exclusive cache as compared to an L1 as compared to an inclusive cache. So these are the disadvantages of inclusion. But when we look at multi-core, we'll see that there will be an advantage of having an inclusive cache in multi-cores, because when you look at multiple cores and there is a shared core, um, we will see that if you do not find data in L3, you do not have to search for that data in L2 and L1 because it will definitely not be present, because it's an inclusive cache. Whatever is in L1 will be present in L2 and that will be present in L3. So if something is definitely not present in L3 cache, so if something is not present in L3 cache, it means that it will not be present in L2 and L1, and therefore you don't have to search those other hierarchies. Now, if we were to discuss the advantages and disadvantages of an exclusive cache, so then the advantage is that if L1 is large in size, then an exclusive cache is better, because in an inclusive cache, you would duplicate the entire L1 in L2, and therefore it would be more disadvantageous. So if L1 is large, it is better to go with an exclusive cache. So the advantages are many. So for example, the capacity of the memory or the cache itself is large now because there is no duplication of data and there is better utilization of the cache space. And then we can fill up L1 without having to wait to fill up L2. So it is going to be faster. And like I said before, if you have an L1 miss, then there is a higher chance of L2 or an L3 hit, because there is more space for new data in L2 now, and therefore the chances of L2 and L3 hit is much better in an exclusive cache. And the other advantage is that if you evict data from L2, earlier we had to do a back invalidation in L1. Now we do not have to do that because it's an exclusive cache. So there is also some time which is saved because you don't have to do back invalidation. Now the disadvantage of the exclusive cache is that whenever you evict data from L1, we're going to fill that up in L2. So if we just go back to the exclusive policy here, whenever we would evict data from L1, we would fill that up in L2. Now that could be one of the disadvantages, because this is going to just keep filling in data into L2 which have been evicted from L1. So this also means that if L2 is not, there's no space in L2. Let us say, for example, we filled up L2 completely and we're evicting data from L1. So we'll have to make space for that in L2, which means that you will have to evict something else from L2. You'll have to replace something else from L2. So we are basically filling up L2 even though there is no miss in L2. So this also means that L2 needs to be large enough to take into account all of those evictions from L1. So these are some of the smaller disadvantages, but mainly for larger L1 caches, exclusive is a better policy. And an even better policy is obviously the non-inclusive, non-exclusive policy. So wherein we do not have the back invalidation issue, which we had in the inclusive cache, and we also do not fill up L2 on an L1 miss. So if you evict data from L1, we are not going to fill that up in L2, and therefore that is an advantage as compared to exclusive cache. So the other advantage is that, like I said, there is no back invalidation. So if you are evicting something from L1, it does not mean that it has been evicted from L2. So there is no back invalidation. And L2 also fills up only on a miss. So you do not fill up L2 like in the case of exclusive policy. You fill up L2 when you evict something from L1. So that disadvantage is also not there in this 9 policy. So that is a brief introduction to exclusive and inclusive caches. The next topic is cache prefetching, and I'll be covering that in the next lecture.